This video is brought to you by YTAndrewPaul Tech Repairs. If you have a console, laptop, computer or MacBook in need of repair in the UK or the EU, then have a look in the description below this video for details on how to contact us in order to organise your repair. Alright, hello there ladies and gentlemen, and welcome to today's video. And today we're going to be taking a look at this 2010 MacBook Pro A1466, and this particular machine has a rather interesting issue. It was sent up by a guy who I've done some previous work for. I believe it's a friend of his who actually owns the machine, and essentially this 2010 MacBook Pro had a few issues with using graphics related products. So things like Photoshop, when trying to install anything like that, it would fall over. When trying to watch any videos and things like that, it would fall over. It would just quit and die. Now, apparently this machine has had a bit of money spent on it recently to try and spruce it up a little bit. So, I mean, actually the touchpads and everything do look rather new and shiny. So I think they've spent some money on sort of refurbing this machine only to find that it's actually got a bit of a problem. So this was sent away to another shop, the name of which does escape me at this moment in time, but they told the guy that he needed a new graphics chip, and the dedicated graphics chip inside this MacBook was dead, and the only way he was ever going to get it to work again was to replace that IC, that BGA chip, with another one, and that was going to cost him the princely sum of 250 quid. Which is probably not too far off what the machines are worth these days. So, you know, obviously, he got in touch with my mate who recommended he sends his machine up to me, and we are going to give it a second opinion. And he should be doubly glad he did, because this particular MacBook Pro is a 2010 A1286 model, and in fact it has the 820-2850 motherboard in there. And if anybody who knows anything about MacBooks will know that this particular year model of MacBook had a big problem, but not with its graphics chip. Indeed, the graphics does sort of die on these things, but it is not related to the graphics chip, and we're going to go through exactly what and why this thing dies shortly. So what we're going to do, we'll show you what it does. So we're going to fire it up first. It will turn on in a sec. Okay. So we're just going to let it boot. So this is from a completely cold boot. The machine hasn't been powered on at all today. I've been testing it over the last couple of days just to make sure it is definitely what I think it is, and I'm fairly happy that I know what it is. Okay, so we're up to the login screen. So the guy has kindly left me his password, so I'm just going to log this in off camera. I'll see you in a sec. Okay, and we'll instantly notice that we're getting a message here that says, if I can just loosen the tripod. Okay, so we'll instantly notice we're already receiving a message from the MacBook which says, if I can get the camera to focus, there we go. You shut down your computer because of a problem. If you want to open the applications that are open when you shut down, click open. If you do nothing, the computer will continue to log in within 30 seconds. It's counting down. So we will just cancel that for the time being, and we'll just let this go. Ooh, is it not even going to get that far today? There we go, that's what it's doing. So we're getting a message there, your computer restarted because of a problem. We'll just take you off the tripod here so you can see that. We would have done if it hadn't. Tell you what, we'll get it to do it again, and I will go and stand in front of the window because this is going to get annoying otherwise. Okay, ladies and gentlemen, sorry for the jump cut there, but this S8 phone of mine has Bixby installed on it. Despite the fact I disabled it once over, it seems to have re-enabled itself on one of the last couple of software updates, and it's sticking its bloody nose in every time I try to put this phone in the tripod mount, which is getting incredibly annoying. So I'm just going to log this in again off camera. Seems to have frozen up. We've got the pinwheel. Okay, so we're just going to say cancel to that one again. It's not the quickest thing in the world, this machine. Okay, so it says here again, your computer was restarted because of a problem. So we're just going to ignore that for the time being. Okay, so we've got to the desktop this time, so that's a start. So let's go into Safari and let's try and load a YouTube video. So we'll try and load a YouTube video up here, and that should kick the GPU in. and then we'll see what it does. Now, the big giveaway was when this was sent up, the guy said that when he tried to do anything graphically intensive with the machine, it would throw an error message at him. Now, usually when the graphics chips die in these things, they start to do things like checkerboarding and all that sort of thing, but that's not what this particular machine is doing. In fact, this is the video I was trying to... Ooh. We will just mute that. We don't want no copyright striking, so I don't know what's going on in here. Should have fibre broadband, this should be nice and quick. Buffering, lovely. Okay, so I mean, it would happily go away and play this last night. So, okay, so it's just kicked into HD now. I think we managed to get the whole way through this trailer last night, and then once we came out of full screen, that's when it fell over. You'll notice there's a clue here, of course. The machine's now been switched on for around 5-10 minutes. So it's getting warmer. Okay, and the fact it's getting warmer and it's lasting slightly longer, it's actually allowing us to use the machine. It's very sensitive still. It will still fall over very easily, but there's a clue there for you into what's going on. Okay, so I'm fairly bored now of this trailer. This is Transformers. It certainly isn't my kind of cup of tea. So what I'm going to do is I'm just going to escape this. You watch, it's going to make me out to be a liar now. It's going to make me out to be a liar. Let's try and full screen it again. We're just going to mess about with it. It won't take it long to fall over, trust me. It never does. Oh, there we go. So let's get this in here. Your computer restarted because of a problem. Press a key or wait a few seconds to continue starting up. And if we leave it a couple of seconds, indeed, what it will do is it will reboot. So there we go. So that's what it's doing. So join me on the desktop. We'll go through the schematics and the diagrams, where I will show you what I think is wrong with this machine. Okay, ladies and gentlemen, so welcome back, and you can see here we have the schematic open for the 820-2850 motherboard we have inside our 2010 MacBook Pro there, and we're going to go through what the issue is. Now remember that this had already been sent away once over for the same issue looking at, and the place told him he needed a new graphics chip, and I'm telling you now that that is not the case. The 820-2850 motherboard had a very, very common Achilles heel, and in fact it wasn't too dissimilar from other MacBook models at the time, whereby the frame buffer suffers an issue with a capacitor. And this is a rather strange and stupid design failure from Apple. Amongst one of many that seemingly plague pretty much all of their devices, if I'm perfectly honest. But this one is particularly stupid, and once we actually go through the repair and what's going on, you'll see exactly why, and you'll be thinking, why the bloody hell did they do that? Why have they done what they've done? Why have they used what they've done? Why have they laid it out like they have? It boggles the mind. I have no idea. I can only presume it's some intern who designed this part of the circuit, and they probably should have been sacked. But anyway, I digress. So yes, the issue is it's not actually down to the GPU itself. The issue is down to something called the frame buffer. Now the frame buffer is a piece of memory which holds essentially a bitmap image of what's on the display at any given time. So it holds one whole frame of the image. So it essentially holds the picture that you see on your display. It then passes that via the GPU to the display over the LVDS. The display picks it apart, puts it back together, and then obviously shows you what's going on. Now that piece of the circuit relies on being fed power. And not just any form of power, but very, very stable power. It can't fluctuate. It's RAM at the end of the day. RAM does not like noisy power. So what it needs is a very well regulated source of power. Now to do that, usually what happens is that all the power rail that feeds the frame buffer in the GPU will get fed through a whole series of capacitors to smooth any noise and voltage ripple and things like that. So you get a nice, clean, constant source of voltage and current. So, the RAM's happy when that happens. However, what happens is with these is they've used a dodgy capacitor. They've used something called a tantalum capacitor. And that's not good because the one thing that tantalum capacitors are very good at, they're quite high capacity for their equivalent size. So you can have a fairly large capacitor in a fairly small package. So obviously they're very good when space is tight, when you haven't got a lot of room to maneuver. Tantalum capacitors can give you a nice big capacitor in a footprint of a smaller, they'll give you say a larger capacitor in a smaller footprint. So they're very good for that. What they're not very good for is in use in high temperature applications. So where there's a lot of heat, because tantalum capacitors die in heat, they cook themselves very, very quickly. So Apple, in their genius, decided to use a tantalum capacitor next to the GPU. Yeah, of course, the GPU is the hottest part of the machine. In a tiny little chassis with not very much airflow to begin with, that's probably a recipe for disaster. But I hear you cry, Andrew, yes, but surely there's not a lot of room in there, which is why they've used the tantalum capacitor. Well, let's have a look. So, the issue we know, or we think we know, is with C9560. And of course, when we look in the schematic, we can see here we have a 1V8, 1V55, 1V35 S0 frame buffer regulator. So this is the circuit which regulates power for the frame buffer. It takes in 1.8 volt, 1.55 volts, 1.35 volts. S0 means it's running when the computer is operational, and frame buffer regulator, because that is indeed what this part of the circuit does. So we're happy with that. So essentially it uses this U9500 IC to take these voltage rails, and in the end it spits out via this little MOSFET here across this coil through these capacitors. It smooths it out and eventually it chucks it out at PP1V8 R1V55 S0 GPU iSense R. And you can see here it says voltage out is 1.806 volts. Now that's very specific. And of course, if our capacitor here at EC9560 dies, or it starts to go slightly out of spec, that voltage rail there is going to be very different from 1.806 volts. The memory that it runs and it controls is not going to be very happy, and the whole thing's going to fall over whenever you try to use your GPU, and that's exactly what's happening here. So we can see here, if we take a look at this schematic a little bit closer, we can see here that it's marked critical because indeed this capacitor is incredibly important to this circuit. It's designated C9560 on the board. It's a 330 microfarad at 20% capacitor, polytantalum. You can see there, polytant. Okay, and it basically connects this voltage rail here across to ground where it smooths everything out, gets rid of any ripple and any noise. So if this capacitor dies, this voltage rail gets very noisy. The power fluctuates up and down, up and down, up and down. RAM doesn't like that. It interferes with the way it runs and it cycles. And then obviously everything falls over and it's not going to end well for your MacBook. And that's exactly what's happening here. So the frame buffer capacitor C9560 is dodgy. So we can see here, look, that we have one end, the positive end, connected to this power rail. The other end is connected to ground. Okay, now remember what we were saying, that tantalum capacitors are used in areas where there's not a lot of room. Well, let's take a look at the board view. C9560. There's our capacitor. We can see here that on pin 1, of course, there we are, we have our PP1V8R1V55S0 GPU iSense R power rail. On the other side, we have ground. Lovely jubbly. What's all this area here then? So there's a few test points. You can see here, test points around the cap. And that's the side our power rail's on. But what's this here? This big empty space just in front of this test point. That, my friends, ladies and gentlemen, is ground. Yes, the same as what this pin here is. That pin there is ground. This area behind pin 1 here this big expanse where I'm rotating my mouse pointer around now, is ground. So you can see there that this capacitor is in a lot of space here where it could simply be utilizing ground. So pin 2 here could be moved here. They could turn the capacitor around and put it in this big massive space here, which would allow them to use a bigger capacitor, i.e. a polymer cap, something like that. And the issue doesn't happen because polymer caps are a lot more resilient than polytantalum. Why did they do that? I have no idea at all. I have not got a clue. I can only presume it's some sort of planned obsolescence where Apple kind of intended it to last a little bit longer than the warranty, and then you all come back for a nice, what is it, tier 3, tier 4 motherboard repair at the Apple store, and they charge you for a new logic board, and yep, that's you on the hook for another couple of years till it does it again, and again, and again, and again. So the disadvantage, of course, behind polymer caps is they're slightly larger. But when you've got so much space around the capacitor, why the hell did they not use a standard polymer cap? Why use a tantalum capacitor in that scenario? I do not know. But that will be the issue with this board. So what we're going to do, we'll get the board out of that MacBook, get it on the bench. We'll take that tantalum capacitor, we'll take that polytantalum capacitor off. We'll put a new polymer cap in place. Everything will be cool. We'll show you it working. And yeah, we'll run some ASDs on it before we finished, just to make sure that the GPU is indeed happy and the frame buffer is good. And then this can go back to its owner. So join us in a sec, boys and girls. We have this out on the board. We have the board out on the table. And let's get to work. Right, okay, ladies and gentlemen, so we have our board now out of the chassis and underneath our microscope camera, and indeed the cap in question, in your view at the moment, this one here, is our C9560. This is our frame buffer capacitor, little tiny tantalum capacitor, and if we take a look in the grand scheme of things, if we just zoom you out a little bit, you'll be able to see just what's going on. So here we have, to the left is the i7-620M. This is the processor, just under here, which I believe makes this the graphics IC, just down from it. So, right next door to our processor lives this little tiny capacitor. Who'd have thought it? And this space around it here is ground. This is our coil here. So I can't remember what the name of that one was. Let's just take a look at the board view for a second. That's the coil that feeds into it there. That's L9560. Obviously, stands to reason, doesn't it? So what we're going to do then is we are going to change this tiny little tantalum capacitor for a more conventional 330 microfarad polymer capacitor, and if we get that into shot right about now, you can see there's a fair old bit of size difference. Okay, there it is, and that's our current tantalum, our new polymer. So you can see there's a fair old bit of difference in size. So rather confusingly, you'll notice there's a stripe on this capacitor, and of course anybody who's familiar with the traditional idea of a capacitor, those cylindrical electrolytic ones, the stripe denotes ground, or the negative side of the capacitor. On these types of capacitor, the stripe indicates positive, just to keep you guessing. So it's going to go this way around here. So you'll notice we've got a little bit of a problem, because what's going to happen is we've got this area here. Now, if we just stick our polymer cap in here, you'll notice that it's going to overlap the fan slightly. So what we're going to do is we're going to nudge this coil here down slightly, so it's going to butt more or less against the side of this, and then that should enable us a little bit more room just to move our new capacitor down a little bit, and then yeah, we should be good to go. So what we're going to do is we're going to get some fume extraction on first of all. And then we're going to apply some flux to our coil, just here. And we'll apply some flux to our tantalum capacitor that we want to get rid of, because these are horrible. Okay, so we're fluxed up. So what we're going to do is we are going to get our Air 1 back. So we're going to turn the airflow down slightly. Now these boards are a real nightmare to work with. And I've left the heatsink on because obviously I don't want to be toasting the CPU with too much heat. So I'm going to knock the airflow down to 65 litres of airflow per minute. And I'm going to divert the airflow away from the processor. So I'm not going to be aiming air towards this. I'm going to be aiming the nozzle over this way towards the capacitor and the coil. So to keep the CPU from as little of this heat as is possible to do so while we be working. Like I say, you'll notice, I've left the heatsink on to prevent any heat buildup in the CPU from actually affecting it too much. And we're just going to go in here and we're just going to heat everything up. Now then, for those of you who've ever worked on these 820-2850 boards will know they're a real git. You've really got to work to saturate the heat into the board. It's not easy to do. So you really do need a good quality air station for this. If you don't have one, well, you're going to need one. So we're just going to keep working back and forth on this till it moves. There we go. Okay, so that's our capacitor out of the way. So we're just going to put some heat into the coil here. Okay, so our coil is off now as well. Lovely. So that's us with the air. Okay, so we're just going to do a little bit of cleanup on this board now. Okay. There's a little bit of heat in the heat sink here. I feel it's not too much, so that's good. So what we're going to do now then is you'll notice that we've got a little bit more space to work with. So the first job we're going to do is we're going to clean the pads of where the coil used to sit and where the capacitor itself used to sit. So we're just going to pop a little bit more flux on here. Okay. And I probably should put some water onto the sponge. Just bear with me a sec, guys, while I do that. I always forget to do that until I come to use it. And then I remember. So I've got to break off from what I'm doing, which is really annoying. So anyway, we've got that now. So we're just going to clean the soldering iron tip off here. Okay. Nearly there. So what I'm going to do now is I'm just going to come in here and we're just going to clean up the pads of any old solder that used to be on the... I don't want it to be there now. And the same down here where the coil used to sit. And well, it will sit again when we're finished, but it's going to sit slightly further down. Okay, so we should have a bit more room now to show you exactly what we mean when we say we're going to run out of room. Okay, so here is our new capacitor. Now, if we buttered this up right against the edge of the pad, you can see there that we're still... You can see the edge of it is just going to overlap slightly into where the fan sits, okay? And of course we have no pad this side because the pad is underneath the middle of the chip. So if we move this slightly further down, you'll see that where the pad is in relation to where the bottom of our capacitor, where the contact is. So that's just not going to work for us as it stands. So we have to do a little bit of work here. So what we're going to do here then is, as I say, we're going to move the coil slightly further down. So the coil in place there, of course, we've removed. Oops. So what's going to happen is the coil is going to move further down here towards this capacitor. Okay, so it's going to sit against it. That's not going to be a problem. So you'll notice there now that the pad, if I can angle this slightly so you can see without knocking everything everywhere, but you can see there that the pads are still in contact. They're just moved, they're just shifted down slightly. And what that will allow us to do is that will allow us slightly more space here, so that when we offer our new polymer capacitor up into position, we'll be able to move this slightly further down. Again, overlapping the pad slightly. Stuck to my tweezer blade a little bit there, but you'll be able to see there that we can angle it slightly more sideways now. So you can angle it this way. And you can see we've got a nice big ground area here that we can scratch a new pad into and leave everything as is. So that's the intention. So there's a little bit of fiddling to do. A little bit of fiddling, but not too bad. So the first thing to do then is going to be to get our coil here, our inductor, in place. So we've moved that now, so you can see it's down against the bottom of this capacitor. Okay, so what we're going to do, I'm just going to swivel this sideways slightly. Pop some flux in. Now then, this could be slightly tricky because I have the big Bertha soldering iron tip on here. We should go from the other side first of all, really. We've got a bit more space that side and we can anchor it in place. So let's just find where you are. There you are. So we've got a bit more flux that side now. Just going to get the old leaded soldering onto the back of our soldering iron tip. I'm just going to give that another clean. Okay, and we're just going to offer up some solder here. This is quite awkward underneath the microscope at arm's length, but you know, we'll work with what we have. In fact, I'm going to change a tip. I'm going to use my slightly smaller tip, which could be fun. I really do need to order like an in-between medium-sized tip for this station. That would be pretty cool. Probably an idea. Something I might do tonight even. Because that would make this sort of job a lot easier. Ah. I don't want to do that. Oh, I've made a mess. Let's get our air one back in here. Okay. Slipped with my hand there. Yeah, we're all human. I'm just going to apply a little bit more heat this side. To the solder will reflow. Should be fine. Okay. Yep, looks good. So I'm kind of hampered by my soldering iron tips here. I used to have all sorts for the Jovi. I've been lazy with this. I haven't bought half as many tips as I had for that. I need to get them bought. I need to stop messing around. Like I said, I've not had any of these sorts of boards to do for a while, so. But it's not an excuse for skimping on equipment. Naughty boy. I'll slap my own backside later when I get home. So, Apply a little bit more solder here. Okay. Just means you have to hesitate the heat on slightly longer with the tip. But, you know, it's not ideal. But there we go. We're all good now. That's on. It's in place. Just going just above it, just to properly make sure it's flowed into position. Make sure it's nice and flat. Okay, seems to be. Nice. Okay, we're good. We're good to go. So you can see now that our coil here now, you can just about see the top edge of the pad sticking out here. So that's where it used to sit. So this coil used to sit another couple of millimeters further up here. So what that's going to do is that's going to give us just enough room to get our new capacitor in place. So I'm just going to get a little bit of IPA on here just to clean up a little bit, if I can find what I've done with my sponge. Okay, so IPA. Just going to get a Q-tip just to clean these off slightly. Okay, so that's where we are. You can see how quickly that's evaporating off the board because there's a lot of heat built up into here now. Okay, so we have that there. So, our new 330 microfarad capacitor. Polymer cap is going to sit in here. So, you can see there's the edge of the pad. So, we can angle this down slightly. Stick it in there. Scratch a new pad in here. And then everything will just go nicely into position, and we can see there that we've got enough space here at the side of the fan to avoid bumping into anything there that we don't want to be interfering with. So that's going to be cool. So what we're going to do then is we are going to pop a little bit of flux down on our pad. Okay, and I want to try and do this with the bigger tip. I think we've got a little bit more room here to get away with it. So remember that this time we want our stripe to go to the positive side, which is there. So our stripe's going towards the pin 1 there where the voltage rail is. Pin 2 is this side, which is ground. Okay, so what we're going to do I'm just going to pop this into position now. So that's our capacitor. I'm just going to try and get myself a slightly better angle to work with. Obviously, I'm trying to do this underneath the microscope, so it's ideal for you to see, but it's not ideal for me to do. And I'm not sure I'm going to have enough room here with this tip again. It's too big. I have to go back with a smaller one again. Hope for the best. I'm definitely ordering some new tips tonight. Definitely ordering some new tips tonight. So, let's just come in this side here. What have I done my bendy tweezers? So I just want to sit these flat where I can. Okay, so we should have that roughly in place. Okay, as before, I'm just going to come in ever so slightly behind, just knocking everything off my desk as well while I'm at it, just for good measure. There really is not enough room to swing a cat in here these days. I may have to find a slightly better way of working. Have a slightly bigger office going forward. Because it's getting, well, beyond a joke here, to be honest with you. So we're just going to go over the top of where the new cap's going to sit with some hot air just to reflow solder into position. We don't want to be blowing it off the board. That would be bad. So I'm just coming in here. Angle it down. Okay, that's lovely. So we'll notice now, look, that our capacitor is sat slightly angled. We have just enough clearance at the edge of this board here now. Okay, so we should be able now to scratch a new padding down here, and everything should be hunky-dory and ready to go from that point. So, okay, so to do that, we're just going to get the edge of this Stanley blade, and we're just going to scratch in so we've got a little bit of a pad scratched in there now. Tiny bit of IPA. So we're just going to apply a little bit of flux. We get a little bit of leaded solder. I'm just going to touch that in down there now. So, when we a little bit of IPA back over this now, should hopefully find and that's us pretty much done here now. Okay, so we've cleaned that up. So all we need to do now is we need to make sure that our board reads as it should do. So we're just going to turn the fume extraction off. We're going to get rid of the hot air. Okie doke. So, just so we can see what's what here. Now then, the one thing to note is that underneath here, you'll notice I scratched to the left and to the right. There was a tiny little test point, which is for, if I remember rightly, PP. It's feedback via for one V8 SO. So you don't really want to be scratching that into ground. So we have just avoided that, which is why I went to the left and the right, and then of course we've just bridged across it. So it should be fine. But we will check it. So we should have pin 1. Pin 1 should go to the side of here. So there's a tiny sort of fuse thing here, I think. What is it? Let's have a look what that is. R513, so it's a little resistor. So it should go to this side here. So if we put our point here, to help if our multimeter was in the right mode, and switched on. Okay, we can hear a beep, 1 ohm. So we know that our positive side of our capacitor is connected correctly. Ground, we should be able to put one probe on any ground hole we like, and here 1 ohm and drop in. Lovely jubbly. Of course, our coil here is in position, and we can see that that's soldered in place. Okay, the one thing that we did want to make sure was our feedback via wasn't grounded. I'll make sure we haven't managed to connect that to ground. I'm fairly sure we haven't, to be fair. But we will just make doubly sure. Okay, so we can test it on the other side of the board, down by the fan connector. Okay, it goes to a few different places. So just around here, I believe something to do with the audio circuit. Is it? Yeah, ORD connector, ORD. So this must be audio. And it looks like it's something to do with this little chip here. There's quite a few little resistors and things around it. There are indeed 3 there. So apparently that same feedback via connects to these 2 sides here. So we should be able to make sure we haven't got any connectivity there. 1 pin on ground. And the other pin here. OL, open line, lovely. So it would appear that indeed it also sits on this pin here. OL, open line to ground, lovely. So we know we haven't gone into our feedback via, because of course if we'd have shot that to ground, we would have been buggered. So that's why we scrape just to the left and just to the right of that little feedback via. Okay, so that should be that. We should be good to go then, ladies and gentlemen. So we have our new 330 microfarad cap in position. And we should be ready to go. So let's put this back in the chassis. Let's fire it up. Let's give it a test. And let's see if we get any more kernel panics. Hopefully not. And like I say, in the end, we'll run the Isd test and just make sure that that is as it should be as well. So join us in a sec, ladies and gentlemen. We've got everything back in the machine, back all assembled. And let's see if we're working now. Okay, then, ladies and gentlemen. So here we have our MacBook Pro all reassembled and ready to go. We're just going to run some Isd tests on this now just to make sure that everything is absolutely hunky-dory. So we have our we have our Isd stick in there. So we're just gonna run through this now and just make sure that this is behaving as it should do. So this is going to take a few minutes to load up. This is the OS version of Isd. It has a few more tests in there that we can run against the machine just to make sure everything is absolutely as it should be. Okay, whatever. Just get rid of that. Okay, so we're going to run a couple of tests on this machine on the GPU side of things. So we are quite happy with everything here, really. The only thing we really need to test here are the video controller external. So the external video controller is the Nvidia chip, essentially. So we're not bothered about memory. We're certainly not bothered about hard drive because those tests can take ages to run through. Let's just let's run through the video controller test. So if we just hit start and let it go. Okay, so we can see that the tests are running now. So we're just going to do sensor tests. We'll just check everything over. Like I said, we know the RAM's good and we know that the hard drive itself is fine. So we're not worried about that. So let's just check everything else on this laptop while we've got it, just to make sure everything's fine. Okay, so once all these have run, we'll show you the end result. Hopefully, we'll have a big past banner across the middle of the screen and should be good to go. Right, okay then, so this is just running through the external video controller tests. So it does quite a few of these sort of weird screen draw things here. With little like polygon shapes and things like that, all of different colours, and then it goes like mesh shadings, and there's a rather cool one of a rocket ship in a not too distant future, if I remember rightly. So there's all these cubes and things. So this is all putting the GPU under quite a lot of stress. Testing its rendering capabilities. Yeah, there's the spaceship. I think it renders it in different colours and things like that in a second. But all this is just testing out its functionality, making sure that it's working exactly as we want it to do. Okay, so again, we'll just let these finish running through, but these are the tests now that that we're really interested in, just to see how these run, just to make sure that we don't get any more kernel panicking or any automatically turning itself off or anything like that. We don't want any sort of abnormalities in these results. We want a nice big green pass banner across the middle of the screen when they're done. But anyway, once they have finished running through, we'll come back, we'll make sure that they've passed okay, and then this one should be good to go back. Right, okay, ladies and gentlemen, so there we go. That's what we were talking about there, that big passed banner straight across the middle of the display there. That tells us that all the tests have run and all have passed. We have no failures. All the external GPU tests have been successful and everything has been absolutely fine. I have to say, over the last couple of days of just firing this up and browsing through YouTube and things, this thing seems to have not skipped a beat since we've replaced that capacitor, and I am very, very confident now that this is the end of the issues being experienced by this machine, and in fact the kernel panics are no more, and in fact we can now confirm that the GPU itself was indeed good all along and the issue was that capacitor. So what the other shop were going to do, I have no idea. I would hate to think that they were going to charge the guy for a GPU and then just replace the cap, because I can't believe that anywhere that knows these machines wouldn't know that that issue exists. So I am slightly skeptical of them. Unfortunately, it would appear we have another fly-by-night rip-off merchant. But as we can see, luckily he managed to avoid them, and he found the right place in the end. So thank you very much for watching, ladies and gentlemen. Hopefully you've found this interesting and you've learned something today. If you have, then feel free to pop a big thumbs up down below. It's always very much appreciated. Like I say, if you've any comments or any questions at all, then feel free to pop them in the comments below. I do try to check them as often as possible, and I will get back to you where I can. Yes, so like I say, if you are in the UK or the EU and you want your own machine fixing, then by all means drop me an email to my business email address. That's in the description below this video. It's YTAndrewPaul@outlook.com. Just drop us a message there with your location, your issue with your machine, and we'll get back to you with a price. Like I say, location's important, so we can give you a quote for shipping. Yes, and like I said, I'm sure we can help you out just like we did with this guy. Alternatively, like I say, if you are worldwide and you're in need of components for fixing these machines, we do stock a few, and like I say, if I can help you out, I'm more than willing to try. Again, that same email address, just drop me your location, your quantities and what you need, and I'll see if I can help you out. So yes, thank you very much for watching. Like I say, if you've got a question for me that you'd rather not air in the comments below, then feel free to hit me up on Twitter. My DM box is open to all on there. It's at YTAndrewPaul. And like I say, you should be able just to find me a DM into there. I do try to pick them up as quickly as I can, really. So thank you very much for watching, ladies and gentlemen. Hopefully this you found this useful. Please remember to subscribe below if you haven't already, and hit that big bell icon. That will notify you of our latest uploads as and when they hit the nets. And yes, so thank you for watching. You've been great. I've been Andy Paul. This MacBook is good to go once more, and I will see you in the not too distant future on the next video. So for me, for now, it's bye-bye. Many thanks for watching then, ladies and gentlemen. Hopefully you've enjoyed this video. If you have, then why not check out these recommendations below. Also, please remember to comment, rate, and of course subscribe to the channel if you found this useful. We've plenty more content on there, and there's lots more to come.